Hi everybody, welcome back to Beginning Algebra. Today we're in section 1.8 talking about simplifying expressions. So here are the objectives we're going to cover today. We're going to talk about simplifying expressions, identifying terms and coefficients. I'm going to show you what it means to have like terms and how to combine like terms. And we will also practice simplifying expressions made from word phrases. This is our last section of Chapter 1, and of course the focus in Chapter 1 is teaching you all the basics you need to start actually using algebra as a tool. So this section again is another introductory level thing, but you'll see next time we will start using all of the things we've learned so far to solve some simple equations. So let's go ahead and get started. Now we're going to jump right into example 1. This says simplify each expression. So really you need to know what they expect us to do when the instructions say simplify. Pretty much the word simplify means for us to eliminate parentheses using the distributive property usually, and then combine any things that can be combined. So when we look at part A, first, I notice there are no parentheses, so that's fine, but I notice that it says 4x plus 8 plus 9. Why not combine these two numbers into one? If you add 8 and you also add 9, you're really adding a total of 17. So this could be simplified as 4x plus 17. Now let's look at part B. I notice that inside the parentheses there really are not any operations I can do. It says 3 times m minus 2 times n. But we don't know what m and n are, so we certainly can't do this subtraction. However, we can eliminate the parentheses by using the distributive property. So I'm going to say 4 times 3m and then minus 4 times 2n, just like we learned in the last section. So 4 times 3m is going to give us 12m, and then we'll have minus, and then we'll have 4 times 2n, which is 8n. Now look at part C. Here we have 6 plus 3 times, parentheses, 4k plus 5, close the parentheses. Now your first instinct here might be to add 6 plus 3 and get 9, and then distribute the 9. But we don't want to do that, and here's why. Remember order of operations. Order of operations is always in effect. So 6 plus 3 would be an addition step. But remember, we have a multiplication step here that's going to take precedence over this addition. We have 6 plus 3 times this sum. So before we add 6 plus 3, we need to distribute this 3. So that's going to give us 6 plus 3 times 4k, which is 12k, plus 3 times 5, which is 15. Okay, now you can see that we really don't need to add 6 plus 3 at all because the 3 is gone. Now you can see that we have two constants here. We have 6 and 15 that can be combined. So I'm just going to use the commutative property to rearrange these last two terms, and that will give us 6 plus 15 plus 12k. And now you can see that the 6 and the 15 should be combined. So 6 and 15, of course, make 21. So this expression can be simplified to 21 plus 12k. And now look at part D with me. Here we have 5 minus this whole parentheses. So 5 minus parentheses 2y minus 8. Now, occasionally a student will get turned around and try to distribute the 5, but the reason we don't want to distribute the 5 is that it's not 5 times this parentheses. It's 5 minus this parentheses. So to eliminate the parentheses here, we need to distribute the minus sign, just like we learned in the last section. So we'll have 5 minus 2y and plus 8. And now we can see that we have a 5 here and an 8 here. Both of these are just plain numbers, what we call constants. And so we can rearrange these terms. We'll have 5 plus 8 minus 2y. And now you can see that the 5 and the 8 can be combined, so that will give us 13 minus 2y. Now remember on the last slide in a couple of the examples, I wrote out the step where we changed the order of the terms so that we could see that they needed to be combined. However, from now on, we'll use the associative and commutative properties without mentioning them. They're always in effect, but from now on, we'll just kind of skip over them and basically take them for granted. So use them whenever you need them, but we just won't actually write out that step anymore. Now let's move on to our next objective, which is to identify terms and numerical coefficients. So I'm going to give you definitions for these things. First of all, a term can either be a number, like a constant, or it can be a variable, or it can be a product or a quotient of a number and one or more variables raised to powers. So here are some examples of terms. 9x would be a term because this is a product of a number and a variable. 15y squared would also be a term because this is the product of a number and a variable raised to a power. -3 would be considered a term because it is a constant. It does not have a variable component. -8m squared n, again, is a term because it's a number multiplied by variables, and this one is raised to the second power. And here is a quotient, 2 divided by p. So this is the quotient of a number and a variable, so it still fits the definition of a term. And here is just a variable, k. So again, this fits the definition of a term. Now let's get a definition for numerical coefficient. A numerical coefficient is just the numerical part of the term. So here are a few terms. Let's look at each of them and pick out the coefficient. If the term is 8, well, all there is to this term is the number part. So for the term 8, the numerical coefficient is 8. For the term -7y, the y is the variable part and the -7 is the numerical part. So the numerical coefficient is -7. You see, it's just the numeric part of the term. For the term 34r to the third, r to the third is the variable part, 34 is the coefficient. For the term -26x to the fifth, yz to the fourth, the x, y, and z factors are the variable part, -26 is the numerical part, so -26 is the coefficient. Here we have the term -k, which can also be written -1k, so the coefficient here is -1. And here we have the term r, which can also be written as 1r, so the coefficient here is 1. And then finally we have the term x over 3, or x divided by 3. Now remember that x divided by 3 could also be written as 1x divided by 3. So you can see here that the number that is multiplied by x is 1/3. And this term can also be written this way. 1/3 times x is the same as 1x divided by 3. And both of these are the same as x divided by 3. So no matter how the term is written, in this case the coefficient is 1/3. Now one thing I want to make sure you understand is the difference between terms and factors. This is a very important thing. Terms are all either separated by a plus symbol or a minus symbol, but factors are multiplied together. So in the case of 8x to the third plus 12x squared, the 8x to the third and the 12x squared are both terms because they are added together. And you can tell they're added because there's a plus sign between them. So always remember that terms are separated by plus signs. However, in the case of 8x to the third times 12x squared, these are not terms anymore because they are not added together. These are now factors. Remember, the parts of a multiplication problem are called factors. So in this expression, 8x to the third and 12x squared are factors because they are being multiplied together. So if two things are being added together, they are terms. If two things are being multiplied together, they are factors. Now let's move on and talk about like terms. So terms with exactly the same powers of the same variables are called like terms. Let's look at a few examples. 9t and 4t would be considered like terms because they both contain a factor of t. However, 4y and 7t would be considered unlike terms because they do not have the same variable. 6x squared and negative 5x squared are considered like terms because they both have the same power of the same variable. But 17x and negative 8x squared are not considered like terms because even though they do have the same variable, they don't have the same powers of the same variable. Negative 2pq and 11pq are considered like terms because they both have the same powers of the same variables. They both have p to the first power and q to the first power. But 4xy squared and 4xy would not be considered like terms because, again, even though they have the same variables, they don't have the same powers. This term contains y squared and this term contains only y. So these are unlike terms. And then finally, 3x squared y and 5x squared y are considered like terms. Notice they both have the same powers of the same variables. But negative 7wz to the third and 2xz to the third are not considered like terms because this one has a w and this one has an x. So they're not alike. Now, in this example, let's just identify pairs of terms as either like or unlike. Notice they're not asking us to do anything to these pairs of terms. They're just saying identify them as like or unlike. So 9x and 4x, of course, these are like terms. Negative 8y to the third and 12y to the second, because they do not have the same powers of the variable, they are not considered like terms. 5x squared y to the fourth and 5x to the fourth y squared would be unlike because, again, they have the same variables, but they don't have the same powers of the same variables. Here we have x squared and here we have x to the fourth. And then 13kt and 4tk. Always remember that your properties are available to use whenever you like. So we could take the factors of this term and rearrange them so that it says 4 times k times t, and then it would look like this one. So even though this term looks a little different from this one, they both have the same powers of the same variables. So these are actually considered like terms. Now that we know what like terms are, like terms can be combined by adding their coefficients together. The power of the variables will not change. All we have to do is add the coefficients. So in example 2, let's combine the like terms in each expression. Here we have negative 9m plus 5m. So whatever m is, if we have negative 9 of them and then we add 5 of them, we will have negative 4 of them. So just add the coefficients. Negative 9m plus 5m is going to be negative 4m. On part B, we have 6r plus 3r plus 2r. We don't know what r is, but if we combine these first two terms, 6r plus 3r gives us 9r, and then 9r plus 2r gives us 11r. On part C, remember that in case you have a variable with no coefficient, its coefficient is understood to be 1. So here, whatever x is, we have 4 of them, and we're adding another one. So 4x plus 1x would be a total of 5x. In part D, we have 16y to the second power minus 9y to the second power. So whatever y to the second power is, 16 of them minus 9 of them leaves us 7 of them. So 16y squared minus 9y squared is 7y squared. And then here on part E, you have to be careful. 32y plus 10y squared, these two terms are not like terms, and therefore they cannot be combined. Now, you'll frequently see instructions that just say simplify. So again, at this point in the course, to simplify means to remove any grouping symbols. Usually for us that means to distribute, and combine any like terms. So let's look at example 3 together. This says simplify each expression. And this expression is 14y plus 2 times 6 plus 3y. Now notice that it doesn't say solve. They're not asking us to find out what y is. They're just asking us to write this expression in the simplest form possible. So for us, that means to get rid of these parentheses by distributing the 2, and then we will see if there are any like terms we can combine. So we'll have here 14y plus 2 times each of these terms. 2 times 6 is going to be 12, and 2 times 3y is going to be 6y. Okay, now I have 3 terms here, and 2 of them are like terms. I have 14y and 6y. So combining the coefficients, 14 plus 6 is 20. That gives us 20y plus 12. And that is as far as we can go with this expression, because this term is a y term and this term is a constant, meaning it does not have a variable component. So these two terms cannot be combined further. Now let's look at part B. This says 9k minus 6 minus 3 times 2 minus 5k. Okay, now remember, order of operations says that we should do any operations inside grouping symbols first. So you look in this set of parentheses and you have 2 minus 5k. So there's really nothing in there that you can do. So now let's think about the rest of the order of operations. There are no exponents here, but we do have a multiplication we can carry out. We can distribute the negative 3 here. So we would then have 9k minus 6. Now distributing this minus 3, we would have negative 3 times 2 would make minus 6, and negative 3 times negative 5k would make positive 15k. So we will write plus 15k. Okay, now let's combine our like terms. I see that we have 2k terms here. We have 9k and positive 15k. So if we combine those, 9 plus 15 is 24. That will give us 24k. And then we can combine our two constants here. Negative 6 minus 6 is like negative 6 plus negative 6, so that's negative 12. So now instead of writing plus negative 12, we will just write minus 12. And that makes sense, right? Because if you're taking away 6 here and you're taking away 6 more here, you're taking away 12 in all. Now continuing with example 3, we will simplify each of these expressions. Part C says negative parentheses 2 minus r, close the parentheses, plus 10r. So our first job is to eliminate the parentheses by distributing this minus sign. That's going to give us negative 2 plus r, and then we still have our plus 10r out here. Now look what we have on this line. We have 2 r terms, so these are like terms. 1r plus 10r is 11r. So that's going to give us negative 2 plus 11r. Now this is fine to leave the way it is. There's really nothing wrong with it. However, in algebra it is customary to put any terms with a variable first, and we usually like to have the constant at the end of the expression. And especially we usually don't like for an expression to start with a negative. So we have an opportunity in this case to rearrange these terms, and we can do that because we still have the commutative property at our disposal. So I could just write this as 11r plus negative 2, or actually I'll just write minus 2. So think about this for a minute and make sure you understand that negative 2 plus 11r is the same value as 11r minus 2. This expression is a little bit better looking, but it's algebraically equivalent to this one, so there would be nothing wrong with leaving this as your final answer. Now let's look at part D. Sometimes people get a little freaked out when they see a fraction. I want you to talk yourself out of being upset at the sight of a fraction if you're one of those people, because fractions are a natural part of the world and they are a natural part of algebra. And the more comfortable you can get handling fractions, the better off you will be throughout algebra or any other level of math that you might take. So let's look at what we have here. Negative 2/3 times x minus 6 minus 1/6 x. So our first order of business should be to eliminate these parentheses by distributing this negative 2/3. So that's going to give us negative 2/3 times x, and then we have negative 2/3 times minus 6, or we'll treat this as negative 6. Now you know negative times negative is going to make a positive, so we're going to put a plus here. And now 2/3 times 6, I'm not going to do in my head, but I'm going to write it down. You might be able to do it in your head, and that's great, but I want to show you a trick that I want you to be able to use whenever you have to multiply a fraction times a whole number. And then we've still got our minus 1/6 x out here. Okay, now let's look for like terms. This is an x term, and this is also an x term. So the first term and the last term are like terms because they're both x. This middle term is a constant term. So in order to add these two coefficients together, you know they're fractions, so we're going to need a common denominator. Let's decide what our common denominator ought to be. And we're not considering this middle term at all because we're not combining with this middle term. So our denominators are 3 and 6. And of course our common denominator can be 6, so what would I have to multiply by here to get the denominator of 6 that I want? Now remember that this x, although it looks like it's next to the fraction, is really in the numerator because this would be considered x over 1. So don't let that fool you. Our denominator here is just 3. If we want to turn it into a 6, we've got to multiply it by 2. So I'm going to multiply 2 into the denominator and a 2 into the numerator. Now in the top, negative 2 times 2 is negative 4, and in the bottom 3 times 2 is 6. And this x, you can continue to write it next to the fraction the way I have it here, or you can just stick it in the top. Either way is fine. Here I've got negative 4x over 6. See, I went ahead and stuck the x in the top. And I'm not going to do anything with this multiplication yet. I'm just going to copy it and handle that in the next step. And then we've still got our minus 1/6 x. Okay, now let's combine our like terms. I have negative 4/6 x and negative 1/6. So adding the coefficients, negative 4/6 plus negative 1/6 gives us negative 5/6. And that is the coefficient of x. So we'll have negative 5/6 times x. And now we've got to do 2/3 times 6. And notice that there are two ways to do this. You could say 2 times 6 is 12, and 12 divided by 3 is 4. And that would be fine, and there's nothing wrong with that. However, I want you to make a habit out of trying to simplify first. Notice that 3 goes into 6. So you can treat that like a division. Let's always try to remember to do the division first if it makes a whole number, and then we can multiply by anything else that we've got there. So here I've got 6 divided by 3. We know 6 divided by 3 is 2. So this 2 times this 2 is going to make 4. And that's it. So that's all we can do to this expression because now we have an x term and a constant and they cannot be combined. But again, remember that it's optional to show this x in the numerator of your fraction. It's just as valid to show it multiplied by the fraction. So your answer could look like this: negative 5/6 times x plus 4. Either way is perfectly acceptable. And now let's look at part E. So here we have 5 times 2a minus 6 minus 3 times 4a minus 9. Now in order to simplify this, of course, the first thing we have to do is remove the parentheses by distributing the factor in front of the parentheses. So I'll distribute a 5 into this first set of parentheses, and I'll distribute a -3 into this second set. Okay, here we go. 5 times 2a is 10a. Then we've got minus 5 times 6 is 30. So we've got 10a minus 30. Now here we're distributing a -3. So treat it like a negative. -3 times 4a is going to be -12a. So we will write minus 12a. And then -3 times -9 would be positive 27. So we will write plus 27. And now you see we've got a couple of pairs of like terms here. I have a 10a and a minus 12a. So let's deal with that first. 10 minus 12 is the same as 10 plus -12. So our coefficient is going to be -2. So this term will be -2a. And then we've got minus 30 plus 27. So -30 plus 27 would give us a total of -3. So I'm just going to write minus 3. And that's all we can do to that expression. So that one is considered now simplified. Here are a couple for you to practice on. I pulled a couple from the homework that I thought looked a little more challenging than the others, and I wanted to give you a chance to try that here, and that way we can go through it together. So pause the video and give it a try on your own. Alright, now let's go through it together. So on this part A, first we're going to distribute this negative, and then we're going to distribute the 7 into this second set of parentheses. So here I've got -1 times 3k squared, that would make -3k squared. And then -1 times positive 5k would make minus 5k. And now distributing this 7 times k squared is plus 7k squared. And 7 times -4k would make -28k. So I'm going to write minus 28k. Okay, now combining like terms, I've got a k squared here and a k squared here. So these two are like terms. -3k squared plus 7k squared will add up to 4k squared. And then we have a -5k and a -28k. So combining these two k terms, -5 plus -28 is going to be -33. So that gives us minus 33k. There is nothing else you can do to this expression to simplify it further, because this term is a k squared and this term is a k, so they will not combine. Then on part B, first let's distribute the -3/4, and then we'll see what we can do about like terms. So -3/4 times x is just -3/4 x. I wrote that as -3x over 4, same thing. And then we've got -3/4 times -8. Now you know negative times negative is going to make a positive. And then we've got to do 3/4 times 8. Now instead of trying to do that here, I'm just going to go ahead and write it down like it is, 3/4 times 8. And then we've also got our minus 1/3 x. Okay, now we're ready to combine like terms. So I see here that we have a -3/4 x and a -1/3 x. These are both x terms and they can be combined, but we need common denominators because they are fractions. So what can we use as a common denominator for 4 and 3? Well, of course, we would want to use 12. So what do I have to multiply by this denominator to get the 12 that I want? I have to multiply by 3. So I'll do that in both top and bottom. And what do I have to multiply by this denominator to get the 12 that I want? Well, I would have to multiply by 4, so I'll do that in both top and bottom. Okay, that's going to give us -3x times 3 in the top here, so that's going to be -9x, and of course 4 times 3 is 12 for the denominator. Let's go ahead and deal with this multiplication because it's not hard to do. We notice that 4 goes into 8. That makes it easy to do the simplifying here. 8 divided by 4 is 2. So now we've got 3 times this 2, that's going to be 6. And now let's continue with our common denominators. We've got 1x times 4 in the top, that's going to be minus 4x. We've got 3 times 4 in the bottom, that's going to be 12. Okay, now we've got these like terms that also have common denominators, and we can add those together. So negative 9x over 12 plus negative 4x over 12 totals up to negative 13x over 12, and then we have this plus 6 that will just sit right here. Now there is a lot going on in a problem like this because you have to distribute, you have to think about your sign rules, you have to think about simplifying this multiplication here, you have to deal with this common denominator and the addition. And so I know it is complicated, but practice will help you learn to deal with all of those different issues at the same time. So these couple of fraction examples that we've done together, I recommend that you sit down with a clean piece of paper and a pencil and copy the problem over and try to work it on your own a couple of times. Use this as a guide, and then after you've gone through both of them a few times, they'll start to get easier for you, and then you'll be able to do the ones in your homework with no problem, and you'll be able to get them right on the quizzes and tests. Okay, now let's get just a little bit of practice simplifying expressions from word phrases. So let's look at example 4 here. It says write the phrase as a mathematical expression using x as the variable and then simplify. So I think the trick here is to not try to work the problem in your head as you're reading it, but as you're reading it, just write it down into mathematical notation, and then you can easily work the problem. So let's read this together. It says the sum of 9, 5 times the number, 4 times the number, and 6 times the number. So there's only one unknown number here, and they've asked us to use x to represent the unknown number. So it says the sum of 9 and all these other things. Well, sum, of course, means that we add them together. So we'll have 9 plus 5 times a number. Okay, we would just represent this as 5x. So that's going to be plus 5x plus 4 times the number, so plus 4x, and plus 6 times the number, so plus 6x. So now we have 9 plus 5x plus 4x plus 6x, and we have these three x terms here that are all alike, so they can all be combined. 5x plus 4x would be 9x, and 9x plus 6x would be 15x. So we're going to end up with 9 plus 15x. Now remember, there's no simplifying we can do here because this term is a constant term and this term is an x term, so these two terms cannot be combined. They are not like terms. Here in part B, we have 3 times a number subtracted from the sum of the number and 8. Okay, so subtracted from means that we're taking 3 times a number away from this other quantity. So we should start with the sum of the number and 8. So again, sum means add. The number and 8 would be x plus 8. And then we need to take away from that 3 times the number. So that's going to be minus 3 times the number. Okay, now you have to ask yourself, what are these parentheses doing? There doesn't seem to be anything to distribute here. So I put these parentheses here because it said the sum, and when you're first starting out, you can't always know if you need the parentheses or not. So I did put them, but now I see that they are not necessary because there's nothing to distribute. So we'll just have x plus 8 minus 3x. So now remember that this x we treat as 1x. So here I have 1x minus 3x. 1 minus 3 is negative 2. So that's going to give us negative 2x. And then we have our plus 8 here. So it's fine to leave this just the way it is. It's customary for the variable term to come first, even if it is negative. And here is part C of the same example. This says twice a number added to the sum of 6 and the number. So we're going to be adding twice a number to this sum. Let's start with the sum. So the sum of 6 and a number, of course, is 6 plus x. And then we want to add twice the number to that. So plus 2 times the number. Now again, these parentheses really are not doing anything because there's nothing here to distribute, so we can just drop the parentheses. And then you can see that we have x plus 2x. So 6 plus x plus 2x is going to give us 6 plus 3x. And that is really all the simplifying we can do. The only other thing you might do would be just for looks. Remember, I've said a couple of times that we usually like for the variable term to come first and we like for the constant to come last. So you might rearrange these. So we could say instead 3x plus 6, but that's not really a simplifying step because this expression is no different from this one. Either one of these would be accepted as simplified when you're entering your answer into MyLabs Plus. And so that's it for section 1.8. There are a lot of good skills here, and if you can get really good at all the things we have encountered in this section, then you will make fewer mistakes than anybody else in your next algebra class, and you'll be all good to go. All of this business with distributing and combining like terms is where people make most of their careless errors. If you'll be really careful and practice here, it will pay off big time all the way through the end of college algebra.